In this chapter, we are going to learn following sessions. 13.1 Impedance and phase angle of series RLC circuits. 13.2 Analysis of series RLC circuits. 13.3 The series resonance. 13.4 Series resonance filters. 13.5 Parallel RLC circuits. 13.6 Parallel resonance. 13.7 Parallel resonance filters. And at the end, we have 13.8 their applications. Without further ado, let's begin. 13.1 The impedance and phase angle of series RLC circuits. Here we have a circuit with one AC source on the left, and on the top of the circuit, there are three circuit elements. Begin with a resistor R, inductor L, and a capacitor C. They are connected in series. Assume we know the frequency of the source, and then we can find out the inductive reactance XL and also the capacitive reactance XC. Let's draw the impedance triangle for these three elements together. As always, anything related to resistor pointing to the right with 0 degrees. So resistance is pointing to the right. And then we have the inductive reactance vector pointing upward. It labels as XL. We have XC pointing downward since XC lags resistance by 90 degrees. The XL leads the resistance by 90 degrees. Our goal is to find the total reactance of the circuit. Since XL pointing upward and XC pointing downward, they point in opposite direction. What we need to do is to find the net reactance. We can get this by using one reactance and then subtract the other one, such as in this case, XL is larger and XC is smaller. We can use XL subtract XC. In our figure here, the blue region, before it was a longer blue vector, but now part of the vector was covered by the yellow vector pointing downward. So the remaining, the leftover blue vector is the remaining, also called the net vector. This is the net reactance of the circuit, of this RLC circuit. So this is XL minus XC in this case. Actually, we are not really interested in the direction. We are more interested in the magnitude. Therefore, we are finding the absolute value of XL minus XC. This is called the total reactance of this RLC circuit. Is the RLC series circuit. And then we can use our impedance formula, the formula that we used in previous chapters for finding the total impedance of RL series circuit, also RC series circuits. Over here is for RLC circuit, but same template. Take a square root and then use R squared plus X total square. This formula is for impedance of this RLC circuit. We are also interested in the phase angle. That's the same template, same formula. The only difference is we use X total. So that is theta equals to inverse tangent X total divided by resistance R. These are very important formulas. We use these formulas for all RLC series sessions and problems. Now let's work on the book example 1. We want to determine the total impedance and phase angle for the series RLC circuit shown in figure 2. And this figure shows we have an AC source, a resistance of 560 ohms, inductance of 100 millihenry, also a capacitor with a capacitance of 0.56 millifarad. Let's begin. So let's put the circuit to the right. We'll have some spare space on the left to work on. First, as always, we need to find the reactance. This time we need to find both reactance, Xc and Xl. For Xc, the formula is 1 over 2 pi frequency and capacitance. That equals to 1 divided by 2 pi, 1 kilohertz, multiply 0.56 microfarad. Punch these numbers into the calculator and we get 284 ohms. And then for XL, the formula is 2 pi FL, that equals to 2 pi times 1 kilohertz, multiply 100 millihenry, that equals to 628 ohms. Now we get both reactance. We are ready to find the total reactance of this series RLC circuit. So X total equals to absolute value XL minus XC. Plug in the numbers, that is absolute value 628 ohms, subtract 284 ohms, and that is 344 ohms. Next, we need to find the impedance of the circuit. That is square root R square plus X total square. And that is square root 560 ohms square plus 344 ohms square. This is 657 ohms. As always, we need to find the phase angle. The phase angle is inverse tangent X total divided by R. That equals to inverse tangent X total is 344 ohms and the resistance is 560 ohms. Put the numbers into the calculator and then use degree, we get a phase angle of 31.6 degrees. It's a good practice to draw the phasor diagram or impedance triangle. So we put the resistor R equals to 560 ohms on the horizontal level pointing to the right, the green arrow here. The blue arrow is the inductive reactance. Through calculation, we know this is 628 ohms. And then for Xc, that's the capacitive reactance, that is 284 ohms. This is the impedance triangle. However, we want to find the total reactance. So one more step. We know the X total is 344 ohms. R remains the same. Now we're going to draw the dashed lines to form a rectangle. Connect the origin to the other side of the rectangle, the corner. This diagonal is the total impedance of the circuit. The angle that's made by this impedance and the resistance R is the theta. We calculate that already, is 31.6 degrees, where the impedance is 657 ohms. Now we finished example 1.